Frictionless wire fixed at R rotates with constant angular velocity omega about a vertical axis RO. O is the origin, R is above O, and making a constant angle alpha with it, and a particle P of unit mass of constant to move on the wire. If the mass of the wire is negligible, distance OR is h and RP is RT at any time, then the Lagrangian of the motion. I have to find out Lagrangian of the motion. So friends, you see that this is my angle, this is the point P, and this is my distance RT, and this is my height h. Okay, and here the motion is omega. So let Pxy be the position. P is the P x comma y is position. This is the point is R. You see, this is the point is R, and this is RO. Okay, so friends, our kinetic energy is equal to T is equal to half into m x dot whole square plus y dot whole square. So it can be written half m r dot whole square, where r equals to root over x square plus y square, and rm equals to r cos theta. So it is x equals to r cos theta, y equals to r sin theta, r equals to r sin theta, and sorry, not theta, it is alpha, because angle is given alpha. So I write alpha. So OM equals to h minus Rm. OM equals to h minus Rm equals to h minus R cos alpha, and V equals to potential energy is equal to G mgh. So gh minus R cos alpha, and Lagrangian L equals to T minus V. So T equals to half R dot whole square minus G h minus R cos alpha. So friends, thanks for watching, and please check the total problem. A frictionless wire fixed at R and rotate with constant angular velocity. This is my wire and this is rotating. So OM, I have to find out OM is the potentiality. So potential difference. So that's why I find out V for potential energy. Thanks for watching.